Hello, UTSA Engineering Summer Camp Counselors. This is going to be our National Instruments project that we'll be hosting for the campers. My name is Ruben Acevedo, and I'll be taking you through the steps required to do such. So like I mentioned, this is going to be brought to us by National Instruments as we're using their NI myDAQ communication device to make the project possible. The end of the experiments will be brought to us by a different company based in Austin called Swan Learning Labs. There we are. And there's 3 separate pieces that are going to attach to that device there. This first one is a 3D printed representation of a CVT, which is the, let's see, composite. Well, it's a variable transmission, and if you change the band here, it changes the load, and it's supposed to represent a transmission in a car. This one you can tell is totally based on cars, as it's got a plastic housing shaped like a car. And what it's going to show is when it connects to the device, it will run software that will turn these motors and will show the load on wheels based on an incline. So if you were to go towards a mild incline, what kind of engine output it would have to require, and then if you increase that load and go higher, what that graph would look like. And as a third project, they bring us this small photovoltaic cell, a solar panel tracker. So it's a solar photovoltaic cell right here on top of a, it's not a motor, that is, a servo, yeah. So this little solar panel on top of a servo, and what it does is it's going to run an algorithm to where it sweeps the area. This little head will move in an angle, and in the software it's going to record where it found the highest intensity of light. And so it's kind of like a digital representation of a sunflower, to where throughout the day the head of the flower will follow the path of the sun to absorb the most sunlight and do the most efficient photosynthesis. This would have it to where instead of just having a set solar panel to where it's only efficient a single part of the day and then the sun moves over here, this would be able to track with the light source, so it's always a viable source of energy. So these 3 are going to be made possible again, like I said, with the NI myDAQ. This will be the middleman between these experiments and the computer. So on the computer end of things, we're going to begin with the software. So on wherever we'll be downloading the files from, whether we have it available on flash drive or if we download it from a master Google Drive account or Dropbox, it's probably going to come in as a zip file. There we are, and if you can see the icon, it looks like a little folder with a small zipper icon on it. And all that means is that it's been compressed down to travel easier over the internet, because there's quite a few files inside of there. In order to make it useful, do anything proper with it, you can right-click it, go to Extract All. It'll bring up this window. You don't have to change anything in the blue field. Just click Extract. There we are. And it brings you to the proper folder. Even if you close out of that one, it's back over here. And now there's a copy of it. So you see the one with the zipper. We've already used that one. Now we're going to be using the conventional looking folder. Double click into there. One more time, UTSA launcher folder for 2010. And we've got all of these files, .vi files, that the software LabVIEW is going to be able to use. And LabVIEW is the software that National Instruments uses for their devices. So we've got these files here. And what we're going to launch up is actually the bottom one, UTSA Launcher. You double click that. And then it's going to bring up a pretty large bit of software, so it may take some time, and we're going to give it a moment to run through its process. Once it gets to an area here with LabVIEW on it, it's going to be talking about licenses. We don't have to pay too much mind here. Just click Launch LabVIEW and it'll have a blue outline on it. So just the one that catches your eye, click that. And then we can click No here when it was talking about evaluations. It wants to extend the evaluation period. We can just click No. And it'll set us on our merry way. So over here with these, if I can show you a little bit of the hardware again, we can place these to the side because we only need them once everything's set up. In the box, the front lip flips up like this, and there's only really two things you got to bring out of here. The main device itself, this rectangular prism, bring that out and give you a view of all sides of it. And the cable for it, which is a USB A to B type cable. Here's what I mean by A to B. There's USB type A on one side, the one we're used to seeing, and USB type B on the other, mostly used by printers. There we are. So you can go ahead at this point, doesn't matter at what point, you can attach the regular USB portion, USB type A, into the computer. And then eventually we're going to bring this other end, if you look at it there, that part fits into the top of the myDAQ. And that's going to serve as both the data port for sending the information through the myDAQ as well as powering it with 5 volts. Place this back in here. And so you see there's all sorts of other goodies in there. Software, DVDs, drivers. There's also other cables on here, screwdrivers and all, but we're not going to be using those for these experiments as they're pretty inbuilt. They're all built in. So we can close that back up and bring over our first victim. Okay, so the software has come up over here after sitting for a second, and what we now want to do is take that cable I had mentioned, the other end of the cable, with one set in the computer, the other one plugged into the myDAQ. Right there, that's the top portion. So where you see the name, right up here. And when you get it in there correctly, this blue LED will illuminate. You get that connected, and then up here in the software, we're going to be clicking on Tools. And it's going to bring down this gigantic menu, but we only want the second option. It reads Measurement and Automation Explorer. Click on that. And you'll just give it a minute to run its diagnosis on the computer and see what it's working with. Look at all the resources. There we are. And it'll bump up with a little more information. What we're interested is in this top left corner over here. So devices and interfaces, you'll see that there's this little arrow, the little triangle to the left of devices and interfaces. Click that arrow. And then I want you to come down to NI myDAQ next to this symbol. Click that. And in name, if this is anything else, which it might be when you get your device, you're going to be changing it to Dev1, DEV1. Once you see that, myDAQ, you've entered Dev1, click Save right here. Very good. And you're set. So we can now move on to connecting the device itself. So we have our middleman, the National Instruments myDAQ, and we have our first experiment. This is the CVT, the variable transmission. If you look at the interface, it has all these little plastic plugs that are aligned. That module will fit perfectly into the side of the myDAQ, and there's no way to get this backwards. You want this sitting on its back on the table, face up, and then this with the business end also facing up. You know, this would obviously be upside down. We don't run it that way. And then those 2 points are simply snugly gonna meet. It's not gonna require any tools. Okay, get this here. Okay, give it a press in. And then you can check both ends to make sure it's made a good fit and place it back on the table. Alrighty. And we're in there. Now to run it properly, we can go back to the computer screen and you're met with this window. Now currently, it's not doing anything. In fact, it's not running yet. In order to start something running in LabVIEW, you come to this area over here, this toolbar, and you click this run command. It's just an arrow pointing to the right, just a regular arrow. And after you click it, it'll look a little more dynamic. And I'll show you what I mean. Now I'm going to click and activate it. There you are. So that's the project itself is now running, but we've yet to send it any signal. So it's ready to do something, but not quite yet. So we've got these 4 divisions: my pendulum, my solar, my dyno, and my CVT. What we currently have, this is the CVT. So when we all get our sets in order to demonstrate to the campers, the brightly colored one with these 2 cylinders and the rubber band between them will be the CVT. So you'll click Run My CVT and Auto Sequence. It'd be a good time to mention that there's also a power cable that comes with the pack. And you'll be able to recognize it by this regular barrel jack that you can plug into any sort of power source. And that'll be found on the back end of all 3 of the experiments. Well, 2 of the experiments. Plug in here, and you've got it going. So we can now see on the software side of things, a graph has been brought up that displays some of the power of the transmission. So if you now click on auto sequence, it will vary that. And as it changes, it's showing different bits of information as far as the amplitude over time and the different ratings for the power being output to the transmission, as well as a display of the vehicle just in its spot. So we look down here and there's this small lever to adjust. So if you can't tell in the video, those 2 are spinning. And as we move the lever, it adjusts that rubber belt between it, changing the power output on the software. So it ran that first white line, and it will then run the second red line, and each one represents a different load on the transmission. It has now just begun the 100% load for the green line under different conditions, and you can change those conditions actively by moving this band, which is supposed to represent changing gears in your vehicle. So that's going to be a really neat experiment to show everybody and really get some hands-on with being able to manipulate both the software, get a physical readout in the real world of that information, and then alter it back. That's going to be pretty cool. So it'll run all those. At any point, we can click stop, and it'll end the simulation. So from there, you can unplug the power to the device. Now that only goes to the 3D printed portion right here. It doesn't plug directly into the myDAQ. And in order to take it out, there's these small metal posts that it stands on. I recommend holding the myDAQ and then pulling out by that post. So it'll get it out safely without messing with any of the 3D printed parts. Place that over there. That's experiment number 1. Experiment number 2, like I mentioned, involves this plastic housing of the car. and the main electronics of it are connected to these motors that then represent the wheels, which are tied together by this belt. And that belt's supposed to represent that if this car were actually on the road, power sent to this wheel or this wheel would affect the other one, which is going to be red information. So given information from the computer and then red information from the computer, and we'll see that up on the software in a second. So it has the exact same interface, those plastic plugs. Bring it into the side